In this lecture, we are going to see how to reduce the quadratic form to a canonical form. First, we will see what is quadratic form. A quadratic form is any second degree homogeneous polynomial is called a quadratic form. For example, you consider quadratic polynomial with three variables like ax square plus bx by square plus cz square plus 2fxy plus 2gxz plus 2hyz. So this is a second degree homogeneous polynomial. So this is called the quadratic form with the three variables. We can write this quadratic form in terms of matrices. So for that, you write x, y, z as a row matrix. Since there are three variables are there, so this is a 1 by 3 matrix. Into write the coefficient matrix. So the first entry is coefficient of x square, and second entry is coefficient half of coefficient of xy. So f. Next entry is half of coefficient of xz. So g. Similarly, here coefficient of yx. So yx is same as xy. So f. And then next is coefficient of y square b, and next is coefficient of yz. So yz coefficient is 2h, half is h. So here also g, h, and then finally the coefficient of z square is c. So this is a symmetric matrix. And finally write the variable matrix as a column matrix. If you multiply these three matrices, then you get the quadratic form. Now we will see how to reduce the quadratic form to canonical form. Canonical form means only the square terms will be there. There is no xy, yx, zx terms are there. So this is the problem. Reduce 6x square plus 3y square plus 3z square minus 4xy minus 2yz plus 4xz into a canonical form by an orthogonal reduction or orthogonal transformation, and find the rank, signature, index, and nature of the quadratic form. So for that, first we need to write the quadratic form in terms of the matrices. So x, y, z, there are three variables. So write as a row matrix and then write the coefficient matrix. So first entry is coefficient of x square. Then second entry is half of coefficient of xy. So minus 2. Half of coefficient of xz is 2. So this is a symmetric matrix. So you can fill the first column also. Next is coefficient of y square, that is 3. Coefficient of yz is minus 1. Half of coefficient of yz, and this here also minus 1. And then finally coefficient of z square is 3 into xyz as a column matrix. So this is the given quadratic form. So let this as x transpose A x. That means this is the x matrix, and this is A matrix, and this is x transpose matrix. Now we need to reduce the quadratic form to canonical form. For that, first find the eigenvalues and eigenvectors of the matrix A. So this is already we found. I am taking from that, so you can verify. If you want, you can go through how to diagonalize the matrix. After diagonalizing the matrix A, we get the diagonal matrix whose diagonal entries are the eigenvalues of A. So we get the D matrix as this one, which is D. Now we know that Q equal to X transpose AX, and the orthogonal transformation is X equal to NY. So from this, where Y is a column matrix Y1, Y2, Y3. Now, if you substitute X equal to NY, then NY whole transpose A N Y. Then what you may get? So AB whole transpose is B transpose A transposes. So Y transpose N transpose A N Y. So matrix multiplication is associative. So what is this? N transpose A N is D. So if you substitute D here, then Y transpose D Y. What is Y? Y is Y1, Y2, Y3. So Y transpose is a row matrix, and write the diagonal matrix also. After multiplying these three matrices, we will get 8y1 square plus 2y2 square plus 2y2 square, y3 square. This is the required canonical form. The question is reduce the quadratic form to canonical form. So that part is over. And another part of the question is and hence find index. So index is nothing but the number of positive eigenvalues, or we can say that number of positive terms in the canonical form. Here number of positive term is 3, so index is 3. And then rank is the number of non-zero eigenvalues. Here number of non-zero eigenvalues are 8, 2 and 2, so the number is 3. Otherwise we can say that the number of terms in the canonical form. Here the number of terms in the canonical form is 3, so rank is also 3. And then signature is nothing but the number of the difference between the number of positive eigenvalues and the number of negative eigenvalues. Here the number of positive eigenvalues is 3, and number of negative eigenvalues is 0. So signature is 3. We can define in terms of canonical form also. The number of positive terms in the canonical form, the difference between the number of positive terms in the canonical form and the number of negative terms in the canonical form. So a number of positive terms is 3, number of negative terms is 0. So difference is 3. And finally nature. Nature is classified as positive definite, negative definite, positive semi-definite, negative semi-definite. Positive definite means if all the terms are in the canonical forms are positive, then it is called positive definite. Here all the terms are positive, so it is positive definite. Thank you.